Welcome to an introduction to decimal notation. The goals of this video are to read a number in decimal notation, compare and order numbers in decimal notation, and also to round numbers in decimal notation. Decimal notation is used to write numbers according to a place value in base 10. A decimal point is used to separate whole numbers from numbers that are less than 1. And we see decimals all the time in our real life. For example, if it costs $2.89 per gallon of gas, the 2 represents 2 whole dollars, and the 89 to the right of the decimal point represents 89 hundredths of $1. If the runner finished the race in 10.3 seconds, that means it took the runner 10 whole seconds and 3/10 of a second to finish. Since the digits to the right of the decimal represent a number less than 1, we can also represent decimals as fractions. Let's go ahead and take a look at that. We want to be able to read each of these numbers and then write them using fractional notation. So for 6.3, we would read this 6 and, for the decimal point, 3/10. So 6.3 equals 6 and 3/10. This is a mixed number. If we wanted to write this as a fraction, we could convert this to an improper fraction. 10 times 6 plus 3 would be 63/10. For number 2, we would have 52 and 12 hundredths. And if we convert this to an improper fraction, 100 times 52, that'd be 5,200 plus 12. So 5,212 over 1,000. Now this does simplify, but we're going to leave it in this form because it does show the place value, and this is often called a decimal fraction. In our last example, number 3, we would have 1 and 125 thousandths. So here's the decimal as a mixed number, and then as a fraction it would be 1,125 thousandths. Okay, let's go ahead and take a look at comparing numbers in decimal notation using greater than, less than, or equal. One thing we can do when we have a decimal point in a number is add zeros to the right of the number, because if I add a 0 here, I'd be adding 0 thousandths and therefore it would not change the value of that number. Now if we wanted to, we could write this as 5 and 219 thousandths, and this would be 5 and 220 thousandths. When it's written in fraction form with a common denominator, it's pretty easy to tell that this number here is smaller than the second. Therefore, we would say that 5.219 is less than 5.22. So really what we're doing when we add extra zeros to the right is we're obtaining a common denominator in fraction form. And I think that's a nice way to do a comparison. On number 2, this has 4 digits to the right of the decimal point, so we'll go ahead and add a 0 here, and when we do that we can easily see that these are now the same number and therefore equal. Another way to compare when you have just two numbers would be to just compare each place value to determine which one is larger or smaller. So what I mean by that is, notice these both have a whole number of 18. If we look at the tenths place, this has 9/10, this only has 8/10. So 18.9 would be larger than the second, therefore it's greater than the second. But I actually prefer to add extra zeros to the right so they have the same number of digits to the right of the decimal. And that comes in very handy when we have a list of numbers like we see here. We want to order them from least to greatest. So we're going to go ahead and rewrite these on the right side of the screen, line up the decimal point and the place values, and then do our comparison. So if we line this up vertically and add zeros to the right so they have the same number of digits to the right of the decimal, we would have to add 1 0 here, 1 0 here, 2 here, and 2 here. Remember, when comparing numbers, the smallest numbers occur to the left on the number line, and the largest occur to the right on the number line. So in this list, I notice there are two negative numbers, and negative 5.8 would be to the left of negative 3.04. So negative 5.8 would be the smallest or least number from the list, followed by negative 3.04. Notice when you rewrite your list, you should give them back in the same form they were given, so we're not going to include the extra zeros. Okay, these two numbers are out. Now because they have the same number of digits, now if we compare the tenths place value, These both have 1/10, but this has 0/10. Therefore, this would be the next number in the list. We have two numbers left, and we have to determine which one would be smaller. If we look at the hundredths place value, this has 0 hundredths, this has 1, so 3.1 is smaller than 3.11. Let's go ahead and try one more. Let's go ahead and rewrite these vertically and line up the decimal point. This number has 4 digits to the right of the decimal point, so let's go ahead and add some extra zeros here. That one needs 2, this one needs 1, and this one needs 1. They all have 12 to the left of the decimal. They all have 0 in the tenths. Next, these two have zeros in the hundredths, so these two are smaller than the remaining two. This one has an 8 in the thousandths, this one has 9, so 12.008 would be the smallest, followed by 12.0098. Okay, those two are out. If we look at the thousandths place, this has 1 thousandths, this doesn't have any, therefore 12.01 would come next, followed by 12.011. Okay, let's go ahead and finish by talking about rounding. Rounding decimals is very similar to rounding whole numbers. Step 1 is to identify the round-off digit. Step 2, if the digit to the right of the round-off place digit is less than 5, we round down, so we do not change the round-off digit. If it's 5 or more, we round up by increasing the round-off digit by 1. In either case, we drop all digits to the right of the round-off place digit. So if we want to round this to the hundredths, step 1, the 2 is in the hundredths place value, and the digit to the right, or this 5 here, is the decision maker. Because it's a 5, we round up, so we change the 2 to a 3, 12.13. Now it's important that we do not include any extra zeros to the right, because this tells the reader we rounded to the hundredths place value. If we added an extra 0 here, it would be assumed that we rounded to a different place value. On number 2, the 1 is the tenths, and the 2 is the decision maker. The 2 tells us to round down, so we'd leave it as a 1, we'd have 5.1, or 5 1/10. And number 3, the 10 thousandths, we have the tenths, hundredths, thousandths. 10 thousandths would be here. The 7 is our decision maker, so we're going to round up, so we change the 2 to a 3. 16.0983, and then we stop. Okay, that'll do it for this video. Thank you for watching.